Okay, let's dive in. We've got some really interesting source material today. It makes this connection that honestly seems pretty surprising at first. We're talking calculus, advanced math, and drying spices out in the sun.
Yeah, it sounds like two totally different worlds, doesn't it? But it's actually a perfect example of how these mathematical tools like differentiation and integration aren't just sitting in textbooks.
Right, they're actually out there being used.
Exactly. In this case, for agriculture, to understand and, well, optimize real world stuff.
And the specific thing our sources focus on is using calculus to measure water loss when you're solar drying spices, like, herbs or chilies laid out.
hmm And that's a tricky process to get right.
How so?
Well, you need to get enough water out to preserve them, get that concentrated flavor, but not too much, or you damage the quality. And the key thing is, it's dynamic.
Dynamic meaning it changes.
Yeah, the speed of drying isn't constant. It depends on the sun, the humidity, how much moisture is already in the spice, lots of
Hmm.
factors. It's always changing.
Okay, so the water isn't just like leaving at one steady rate. It speeds up, slows down, maybe?
Precisely. And that is where differentiation comes in. It's the tool that lets us figure out the instantaneous rate of change.
The speed at any specific
Oh,
moment.
exactly. The speed of water loss right now. So if you take measurements, you can sort of build a mathematical picture, a function showing how fast water's leaving at every point in time.
Okay, I get that. We can track the speed moment by moment using differentiation.
Yeah.
But how do you figure out the total water gone from beginning to end? If the speed keeps changing, that sounds complicated.
And that's the perfect setup for integration.
Okay.
Because if differentiation gives you that function for the rate of water loss,
The changing speed.
right, integration lets you add up all those tiny instantaneous changes over the entire drying time. You're summing up the effect of that changing speed.
So it accumulates all the little bits of water lost second by second, even if the rate was different each second.
That's it, exactly. The end result of the integration is the total water that has evaporated from the spice.
Wow. Okay. So differentiate finds the rate function, integrate that function over time, tells you the total amount removed. That's much more precise than just, I don't know, weighing it at the start and end.
Well, yes, because it accounts for the how. It
Right.
gives you insight into the process itself, and the source material really highlights why this matters.
Right, the practical side.
Yeah. Knowing this precise water loss helps you figure out the optimal drying time. You can predict how, say, a cloudy day might affect things. You get consistency from batch to batch.
And better quality spices, presumably, hitting that perfect moisture level.
Exactly. It takes some of the guesswork out. It turns this traditional method into something much more controlled, scientific even.
It really is fascinating, taking abstract math and using it to make sure, the paprika in my cupboard tastes right and lasts longer. It just shows the stuff isn't only for engineers or physicists.
Not at all. It's fundamentally about describing change, and change is everywhere, especially in natural processes.
So to wrap this up a bit, the main takeaway here is that calculus specifically, these tools, differentiation and integration, gives us a really powerful way to measure and understand processes involving change over time, like water evaporating from spices.
hmm It's a great reminder that math isn't just theory. It has very real, practical applications, often where you least expect them.
Hidden in plain sight kind of thing.
Definitely. It makes you start looking around, doesn't it? Wondering where else these ideas are working behind the scenes.
Absolutely. Which leads us to a final thought for you, the listener. If differentiation helps understand rates of change and integration adds things up over time, think about spice drying, sure, but what other everyday things involve something changing or accumulating? Could calculus be playing a hidden role there too? Something to ponder?